Best way to get started with Azure Remote Rendering is by visiting the developer documentation. We're always keeping it up to date. We take a lot of pride in the docs, and there's sample projects in there as well. So from a quick start that you can deploy to Unity and upload your model and get it all running within about 30 minutes to a showcase that's more of a commercial type scenario where you can have a user interface and gesture support via MRTK. So you can see those two starting points. The other thing that's really cool is it's called the ART tool, and it's the Azure Remote Rendering tool. And it's a desktop binary. It's pre-compiled if you want to just download the executable. All you do is plug in your account credentials and hit start, and you can see any content that you've uploaded remotely, or you can see the kind of built-in assets if you need to get started even quicker than deploying a Unity project.
Hi everyone, welcome in the immersive room, and this time I actually have Finn Sinclair with me. He is currently working on the MRTK3 at Microsoft, helping building the future of interaction UI and developer tooling. So welcome, Finn.
Hi, it's great to be here. Thank you.
Yeah, good to meet you too. So can you tell a bit about yourself?
Yeah, absolutely. So I'm Finn. I have been working on the MRTK middleware developer tooling team here at Microsoft for about a year and a half to 2 years now. And I was also an intern on the team a while back, and it's been a blast. We build developer tooling for both our own internal teams, building our own internal products at Microsoft, as well as for the open source community. And it's just been a blast because everything we do is completely open source, and we love community contributions, and it's pretty unique kind of situation because I don't think a lot of other teams at Microsoft can really say that it's a collaborative effort with the open source community. So
I can imagine that. Can imagine that. I'm really looking forward to this session. I'm actually starting also some project with MRTK3, so I'm specifically curious about this part. So
yes.
So I will give you the floor, and I will get back to you after the session.
Awesome. Thank you so much. Alrighty, so hello everybody. I know I just gave a little intro, but I can give another short intro here, just I guess about my background if you were interested. So I've been kind of in the AR/VR space for quite a while now. I've been hacking on my own VR software since about like 2016, 2015, back when the first, consumer VR headsets came out. So I've kind of been on that side, like the whole, I'm familiar with how to build, games and apps for both, entertainment, education, enterprise, all that good stuff. I've played with a whole bunch of different, VR frameworks in the past. I know many have come and gone, and it's been a wild ride to get to where we are here today. I've worked on my own projects. I worked on the Qualcomm XR Runtimes team. Obviously, I've worked here at Microsoft, and I love everything open source. So on the MRTK team specifically, I'm kind of like the hands and UI guy. So I do a lot of our interaction and input, as well as our UI, which I'm going to talk about a little bit later. But that's kind of what I'm up to. So I guess I guess this talk is mostly gauged towards people who have had a passing familiarity with MRTK2, like V2, like the current, in-market version. And you might not have built an entire, full app with it, but you might have, been familiar with it in passing. Either maybe have a positive experience with it, maybe a less than positive experience with it. But I think the main hook, if you're at all familiar with MRTK2, right? Some of the interesting things in MRTK3 are like what are the equivalent of like those ubiquitous, like profiles and configurations from MRTK2. It's like we don't really have them anymore. We don't even have like the concept of like the focus provider. We don't even have to do our own controller mapping. And we don't even have to bind like the visuals of our interactions to the input anymore. So like this is a huge rethinking of a lot of the different ways that we've typically done MR interaction, and it's really exciting because this is a fresh slate. The reason we're even calling it MRTK3 is that it's really thinking about it more like a new product than an update. And the way that we're doing a lot of this is with the XR Interaction Toolkit, or XRI. And you might be familiar with this, you might not, but this is one of the newer packages that Unity themselves have been working on. And it's basically a low-level, just kind of abstract interaction system. And so it doesn't try to solve all of the problems that MRTK does, but it tries to be a really, really good kind of foundational glue that can kind of represent abstract concepts like, controllers and interactors and whatnot. The way I describe XRI, and I know that XRI is a big thing, so a lot of people might have already been familiar with XRI, but at its core, it's basically just a many-to-many mapping, right? You have a bunch of interactors, and XRI really doesn't care what these interactors are, right? XRI doesn't make assumptions about, a controller or a hand or a head. It's just an interactor, and you can make whatever interactor you want. Or you also have any number of interactables, and you can have many interactors to one interactable. You can have one interactor to many interactables. It's very open-ended. It can basically represent through these primitives any sort of interaction that you might want. And so this has been an amazing partnership. So we've actually been collaborating with them pretty tightly over the last year and a half or so. And we have been talking with their team pretty tightly, and it's been really, really awesome because we've been able to suggest, improvements, and we've been able to lend them our experience and our expertise from dealing with, years and years and years of, working with XR interactions. It's honestly great. We have literally nothing negative to say about it. It's been an amazing collaborative experience. It's super fast. It's super tiny, lightweight. And the best part is that it's maintained by Unity, right? So now a huge chunk of like the MRTK API surface is no longer even maintained by us. It's actually part of basically the engine, the platform, which is really, really great because that means that we get better API stability, right? And it's less overhead for us because we're a tiny, tiny, tiny team here at Microsoft. And it might seem like we're some huge team, but we really don't have that many people. So if we can defer some of these core platform responsibilities to the engine itself, that's awesome for us. And another good point is that it's kind of becoming this interaction standard across apps and platforms, right? Because MRTK isn't the only platform or middleware that is using XRI, right? Like, for example, a lot of new XR devices that are coming out these days, their SDKs and their sample apps are all built with XRI too. And so the general rule of thumb is that if it's working with XRI, it already works with MRTK. And so I'll talk a little bit about that in the later part of this episode. But if you think about it, right, with OpenXR, with the Unity abstractions, gone really are the days of having to build plugins and features to support different devices. A lot of the time, new devices just work out of the box, which is crazy. Like, this didn't happen before. A good example is Snapdragon, Qualcomm came out with these new AR viewer glasses, right? And they're adherent to OpenXR. And it basically just worked in MRTK3 without us even knowing that the devices existed. Like, they had MRTK3 running with XRI and MRTK and OpenXR before we even knew the device existed, which is crazy. Like, that is unheard of, from the old days. So, and again, the big takeaway here is that we can leave the basics to Unity, right? Like, Unity does this really, really, really well. And, we can leave it to them. So a little bit of a breakdown on how we map these primitives, right, to the kinds of things that you come to expect from MRTK, right? Because if you're building an app with MRTK, you expect things like hand raise and air taps and pinches and grabs and all these kinds of normal things that MRTK apps have. And so we basically, have these controllers, and a controller is not necessarily a motion controller. It could be a hand too. It's basically just any arbitrary source of input. And we can just scatter as many interactors on them as you want. We've got our poke interactors, our grab interactors, ray interactors, all different kinds of input. But again, these are all just XRI interactors. Some interactors don't even sit on a controller. And this is part of the amazing flexibility of XRI. You can use the exact same interactor system that you do for your own finger pressing a button or doing some interaction or manipulation as you do for like an inanimate object. You can attach an interactor to literally anything. You could attach it to a robot arm that's controlled by a joystick. You could attach it to like a stylus. You could attach it to a physics object. The sky's the limit. It's insanely open-ended, which leads to really fun interactions. Like you can grab the stylus, which has a poke interactor, and just like chuck it at a whiteboard, and whenever it hits the whiteboard, it makes a mark through the same code path that your actual finger would use. So it's really flexible, and it's a blast to work with. The other big idea here, right, is that a lot of the time in MRTK2, there was a really tight coupling between the underlying like state of the interaction, meaning like are you selecting it or not, and what it looked like, right? So we had all these pressable button scripts that would that would like move the front plane of the button or like change the shape or change the color and everything, and that worked well except for the fact that you couldn't really customize your own visuals, right? Like a pressable button was a pressable button, and it looked like a particular thing, and it worked in a particular way, and it wasn't super flexible. In MRTK3, we split the two. We have this really, really big separation, basically, between the underlying state of an interaction and the visuals that are driven by that interaction. And we have this thing called State Visualizer that does that for you, but that's sort of beside the point. The main point here is that you can change what an interactable looks like. Like you make it look completely different. You could change it from a pressable button to a squishy stress ball to a lever to anything, but the underlying state can be shared between everything. So that's really, so like on this example, right, we have our typical UI buttons, then we have like those chunky 3D buttons, we have piano keys, and they're all underlying the exact same interactable. They just have different visuals associated with them. Another great thing that we can get from XRI is that we don't have to really do any extra work to do multi-handed interactions, because XRI is just a many-to-many mapping. So, interactor on this hand, interactor on that hand, voila. 1, 2, 3, as many interactors are participating on something, right? All of the interaction logic is unified, right? So we don't have a special like, oh, I'm being, controlled by one hand, or I'm being controlled by two hands, or the right hand or the left hand. It's just like how many interactors are interacting with me. Let me compute this algorithm that determines, the interaction to take based on all of the poses of the different interactors. So that's really nice. It's a lot more sane workflow under the hood. The other thing is that XRI has awesome tooling itself. Like they have these amazing debuggers that will show you the state of every single interactable in your scene, show you what all the interactors are doing, where all the events are going, where the colliders are. It's really, really awesome. Just again, I know I keep praising them, but like shout out to the XRI team at Unity. They are awesome. This also brings with it a different approach to the rig. And I think, like in my opinion, and people might have different opinions about this, but in my opinion, this kind of rig design is so much nicer than the way we had it before. This is sort of like a WYSIWYG rig, if that makes any sense. What you see is what you get. You don't, like, we never, ever spawn objects for you at runtime without you basically explicitly telling us to do so. So a lot of the way that MRTK2 worked is that as new pointers or input devices were discovered on the platform, we would instantiate and spin up new pointers and controllers and whatnot. It works a little bit differently in XRI. In XRI, the rig is a prefab. It is actually a physical thing in your scene that you can customize and set up, which is awesome for like game developers and artist-driven workflows where you want to make your hands look different or physically attach something to the hand, or you want to know exactly where the head and the hands are at edit time to like construct an avatar or a pose or something. Like all of these things, it's very what you see is what you get. If you want to add new controllers, you literally just add a new controller game object. That's it. You don't need all of these controllers and interactors that we provide by default. This is just kind of like our good starting point. You can even use the default XRI rig that comes by default. We still support that. You just won't get all of the necessarily the spicy flavors that we have with our rig. So yeah, our rig is just a starting point. And as you see here, some interactors aren't even on the rig. Some interactors don't even have to be on a controller, right? So like our speech interactor, for instance, that's not on a controller. There is no such thing as a speech controller. So there's just, a speech interactor hanging around, and that's okay. What if you want to build your own interactor, right? Because that sometimes eventually happens. Say you have some cool new peripheral that your company is building, and you want to build an MRTK app that supports, some new gizmo that you're building, right? You might need to build a new kind of interactor to describe how that interaction works, right? It is so easy to build new custom interactors. It is so easy. The way it works basically is at the code level, you just you subclass an interactor, and you just fill out this delegate, this function that the system calls. The system calls get valid targets on you. You tell it what your targets are, and it already works. Like that is genuinely how simple it is. XRI handles all of the input bindings for you. It handles, and those bindings are done through the Unity input system. So if you're familiar with using the normal stock Unity input system for anything, it still works. There's not even any MRTK code associated with this. Like genuinely, this is not an MRTK interactor. This is not an MRTK binding or pointer or anything. This is literally just subclass XRI interactor. You're good to go. And the cool thing that I'll talk about in a couple slides is all of our interactables already work with all of the vanilla XRI interactors. So you don't have to actually implement any MRTK interfaces or subclasses or components or anything to actually get interaction working with our interactables. So if we're using XRI for everything, right? I guess a good question is like, what are we actually bringing to the table then, right? If XRI is handling our input bindings now, I guess the input system is handling the input bindings, but if Unity is handling the input bindings, if Unity is handling our interactions, our interactors, our controllers, what are we bringing to the table exactly? And so this lets us focus on what we do best. And I think a lot of us on the MRTK team, we really enjoy things like UI. We really enjoy, making new kinds of interactions with new interesting, human interface design elements, new human-computer interaction principles that, can make it easier for you to interact with your holograms, right? So we have, new interactors that are tuned for, the kinds of interactions that we do. So we introduced this idea of gaze pinch. There was limited support for MRTK2, but it's now front and center in MRTK3, where we have fused gaze and hand interactions, where you can basically indirectly manipulate various things based on where you're looking with a hand by your side. And it's really easy. It's really satisfying to use, and we think we think you're going to love it. Obviously, we have speech support, gaze support, volumetric pressable interactables, which aren't necessarily supported by XRI by default. Obviously, we have all kinds of new interactables for you to play with. We have our classic object manipulator that's been reworked for XRI. Obviously, we have our pressable surfaces. We have sliders, whiteboard type interactables for drawing. We also have this concept of a stateful interactable that can, not only does it expose some nice new events for you to subscribe to that XRI doesn't necessarily offer, we also offer this concept of variable selection. So in XRI, by default, things are just either selected or not selected. It's binary, like you click the button or you haven't clicked the button. In MRTK, we extend this concept to actually have this variable selection concept where based on how much you're pinching or how much you're pulling down the trigger in your controller, the actual state of the interactable itself can variably change. And that's also tied in with the pressables. So when you're pointing at something and you slowly pull the trigger, or you slowly pinch, or you slowly push down with your finger, that's the exact same code path. Every single object, if you use our stateful interactable, actually has this concept of sort of being, analog-y selected, which is really, really useful for building really cool, new, satisfying XR interactions. But so when we're building this, right, we kind of run into this tricky question, right? As part of MRTK3, one of the other big advantages is that it's hyper-modularized. We're no longer one big chunk of code. We're like a million different packages. Not a million, but like probably at least 8 by now, maybe 10. And so we have these strict boundaries between packages of what they're allowed to know about. It's because we allow people to basically take different packages a la carte. Like, do you want our interactions but not our UI? Okay, cool. Do you want our UI but not our interactions? Okay, cool. You want, a button but you don't want, all of the object manipulator stuff? Then sure, right? So we allow people to kind of mix and match a la carte these packages. The problem though is that, our interactables are like in a totally different package than, say, the input package, right? And so how does like a whiteboard interactable know that you're poking it? Like, how does it even know what a poke interactor is? How does, the pressable button interactable know that gaze pinch exists? It's in a completely different, package. How does object manipulator know about the new interactor that you build, right? When you build a brand new interactor out of the box, how can object manipulator know how to be manipulated by that interactor, right? It's because the object manipulator, not only would it not have a reference to your class or your interface, it also would have no idea, what sort of manipulations that interactor encodes. And so the core problem here, right? How do you build new interactions? Like we come out with this new gaze pinch interaction, or you come out with your new, gizmo interaction. How do you build that new interaction without having to go and rebuild every single interactable that you've built to support that new interaction? And so like when we were implementing gaze pinch with MRTK2, we were having to do some of that. We were having to encode some of that gaze pinch logic into the interactable itself, and that wasn't going to work, right? So the secret is they really don't know. So how do they know? They don't know. All of these interactables, they actually respond to all interactors in the exact same way. In 99% of all of the cases, the interactables literally don't even know what the type of the interactor is. All they know is that it is an interactor, and they can respond to every single interactor in the same way. And so, and obviously we have some edge cases here, but we use interfaces for those because sometimes we have to do slightly different things for like poking versus something else. So we use interfaces in those cases, and those are in our core package. So all the packages can talk to it. But again, how do we do this where every single interactor is basically treated exactly the same way? Like, how is a grab with your hand up close, computed in the same way that a ray is? Like, how does that even work? So we have a few generic events, right? So all interactors hover, select, and activate. This is from XRI. Every interactor does this, right? It's not special for one kind of, grab or poke or ray or whatever. These are pretty much universal, right? They also support the multi-selection, right? So if you're selecting with multiple hands, you have like on first hover, on last hover, all that kind of stuff. But again, how does a brand new interactor like a grab or a ray or a gaze pinch or a gizmo actually describe what it's doing, right? Because if your object manipulator, right, if your interactable has no clue that your interaction even exists, right, how could it possibly encode something like, gaze pinch? Because it doesn't even know it exists. And so the secret here is that the interactor describes this pose, this attach transform. And it's kind of like this universal point of manipulation, right? And that's intentionally vague because it means different things depending on what sort of interactor you're talking about, right? So if you're on a ray interactor, right, it'll be the point on the object, right, where the ray hits. Because think about it, if you have a ray and it hits the object, right, and you're going to now move that object around with your ray, the attach point is on that object. For grabbing an object, obviously your attach transform, right, is like, on the hand. It's wherever wherever the attach, wherever the user is actually physically grabbing the object, either with a pinch or whatnot. Poke, obviously, it'll be where you're poking with your finger. Gaze pinch is a much more complicated set of math, but basically it's the target object center with a centroid offset thing. Again, you don't need to worry about that. The interactable doesn't need to worry about that. The interactable has no idea gaze pinch even exists. All it knows is that there's an interactor and it has a attach transform. Who knows how it was made? Let's just follow it. Your new interactor with your gizmo or whatever you're building, you can describe that attach transform however and anywhere you want. You can make that attach transform driven by hand joints, your input device, by the network, by some heuristic, by who knows? It doesn't matter. But the point is that if you describe that attach transform as your universal point of manipulation, whatever that means for your interaction, all of our existing interactables will work. So it's kind of a universal behavioral or semantic interface for how to describe manipulations and interactions. So what do we get from this? Like from all this blab, what's the actual benefit, right? So obviously, XRI interactors work with XRI interactables, right? And our interactors would, of course, work with interactables. But you also get vice versa. You also get the abilities for our interactors to interact with existing XRI interactables. So if you have an existing XRI project, you can actually bring our input and interaction into your project if you'd like. It will not only will it work with your existing XRI rig, but it will also work with your existing interactables out of the box. No configuration needed. Any other way around. If you have some rig set up in your project already that is using all of these XRI interactors, and you want to use our buttons, say, right? It already works. It just works out of the box because they all understand this common language of, these interactors and these attach transforms. And like I said before, this helps us split into the modular packages, right? Because these interactables don't need to have any knowledge of what the interactor is. That logic is completely isolated. So like what I mentioned before, right? We have this variable selection idea, right? Where you can see on the left, right? It's driven by like the pinch, right? It's also driven by poking, right? So as we poke a button, right? It's that exact same variable selection, value. It's driven by both. So this unlocks pretty interesting kind of use cases where you can actually it's not a per interactor thing. It's a state of the interactable. So you actually get these interesting things where, you can variably select with two hands at once and it's coherent, right? Like as you variably select with one, right, you can kind of like select with the other and it all kind of makes sense. You can push a button that has been, pinched with the other hand and it all makes sense physically because the selection progress of that interactable is actually a state of that interactable itself. We don't have to really go over this, but this is kind of what this looks like in the code, kind of. We essentially take the max, right, of all of the participating variable interactors, as well as the max of the non-variable interactors, right? And so what this gives us, right, is you can have as many fingers pressing the same button as you want. You can have as many rays variably selecting the same object as you want, and it'll just kind of be coherent. It'll just take the max of all the participating interactors. Same thing with pressable button, right? Like we'll take the max of the our variable selectedness, and we'll also add in like the pressed value physically from your finger on the button. But again, it's the same number. It's the exact same number. So if you have some kind of visual layer that's driving your button pressedness, it'll still be the same visual feedback regardless if you are pulling the trigger on a motion controller or if you're pinching or pushing. It's the exact same code path, which makes your life so much easier. So it's all the same. So where does this get us, right? Like we've built out all of this foundation, right? We've built out all of these amazing new interactions. We have this new rock solid foundation with XRI, right? And everyone's happy because we're using Unity constructs instead of building our own. Our packages are more modular, so you can only use what you need, more performant, awesome, more extensible, great. But what can we do with this, right? And one of the big things that you'll notice in MRTK3 is this drastically overhauled UI systems, basically. And so in MRTK2, we had some experiments with using Unity UI constructs for 3D UI. And we've kind of doubled down on that in MRTK3, where we now basically offer optimized UI design system that is all volumetric, all 3D, and works with automatic layout and other typical creature comforts that you would come to expect. So you can see here, we have a lot of really beautiful kind of micro interactions here. A lot of really gorgeous shader effects that are driven through our sister project, MR Graphics tools. And a lot of this is all powered by that state visualizer concept I mentioned earlier. So, all of these, UI, effects and states are all driven by the exact same state visualizer system that, you would use to make your piano key move or an object, turn blue when it's grabbed. It's the same unified system for UI and interactables. So, what exactly are some differences between what this workflow has and what you might be used to, right? So what we do is we kind of combine the canvas rect transform layout that you are expecting from like normal flat 2D UI, but we bring our volumetric 3D UI design and shaders to it, basically. And so you get kind of this happy medium where you have this super satisfying, rich, 3D experience with, fingers touching, pressing, squeezing, pinching, all these really fun micro interactions. But you don't have to manually lay this out anymore. You don't have to, take a sticky note and start, hand computing like, spacings and, all of our bespoke like object bar and, scrolling object collection. All of those things kind of become defunct because Unity does that for you. Unity already has this UI system, and it's not perfect, but it does do a lot of these things for you. So now you can basically describe all of your app layouts with real constraint-driven layout, right? So again, like I have a whole entry on my website about this if you want to go read up. But like this is a huge paradigm shift from how people are used to building volumetric UI in MRTK2. Because in MRTK2, right, everything was either manually placed and authored, or you used one of our bespoke, object bar scripts, or you could use our Unity UI stuff, but it was a separate it was a separate interactable workflow, right? So here, it's the exact same constraint-driven layout workflow for the 3D objects as you would expect for the 2D UI. So none of this is scale driven. So the one thing that we would see people doing a lot, right, is if you wanted to resize a button, you would have to do this thing where you would scale some elements of the tree, and you would have to isolate some parts of the tree to scale to make the backplate bigger, and nothing obviously would automatically size to fit contents because that was not really super possible. And scaling buttons and resizing buttons was never as easy as just grabbing the corner of the button and moving it. You had to either dig into a custom resizable button script or change the scale yourself. And changing scale for UI size is also a huge nightmare because if you do it wrong, any UI that's lower in your hierarchy, all of your design sizing metrics are going to get totally thrown off, right? So here, right, we have this unified design system with unified units all the way down the hierarchy. There's no scaling involved. You just resize. You can specify dimensions. You can specify constraints. If you've used the Unity UI systems before, this is all trivial and obvious to you. But if you've only ever used our static, unresizable, manually laid out MRTK2 UI, this is going to blow your mind. And obviously, we have all of the normal things like, reflow, where if you have, some kind of dynamic layout, as you increase or decrease the number of objects in your layout, obviously things can reflow, they can resize. You can fit parents to children, you can fit children to parents. You can also just customize, the margin and padding in the very normal and reasonable way. Instead of having to do some kind of custom script for this or author it manually, again, it's just properties of the layout system. The other really, really cool thing is we get clip and scroll kind of for free. It's not truly free because we need to do our own work with, near interactions and touchable scrolling. But we get 3D scrolling and clipping by default in a way because we can clip both the visuals in a perspective correct way, as you can see here on the right, where the actual 3D cross-section, the actual cross-section of the button is preserved as it gets scrolled off. So that's really cool. But we also get things like we could even clip colliders, because it's really easy to extract the 2D footprint of a mask in Unity UI. And so we can basically run this little script that per millimeter accurately clips the edges of our button colliders off the edge of a mask. And so you no longer have these problems of like you're scrolling these 3D buttons off of a clipped, view, and the button is sort of kind of halfway off the edge, and you can still press it. The collider itself is per pixel accurately clipped to the edge of your mask, which is just awesome. This design system, right, has been vetted internally quite a bit. We're building a lot of our internal projects on this. It's basically designed to be scalable across a very large team, because we have, over 100 technical artists, engineers, designers, all working on huge code bases. And, the days of, manually placing and authoring UI, they had to go, right? We need a modern, composable, auto layout UI system. And so, not only with our UI layout, but also with our visual layer, right? So this is showing all of the cool different things that you can do with that state visualizer component I was talking about earlier. And state visualizer, right, is designed that for, in a very, very easy way with no code, designer-driven designer-driven workflow. You can basically author all of these fun little micro interactions, like that little toggle switch doing its little grow and shrink, or these pulses, or the glow of the back plate as the front plate approaches it. All of these are just driven in a no-code way through State Visualizer. And so I don't have time to go through State Visualizer itself here right now, but I really urge you to guys to go take a look at the MRTK3 docs. We have a big write-up on State Visualizer, because it'll be a hugely useful tool for you. Obviously, not everybody has, a HoloLens or even a VR device, right? So we make sure that we support accessibility requirements as well as 2D support. So by leveraging these Unity UI primitives, we get all of these other features like directional navigation, gamepad support, and mouse, keyboard, all these kinds of things that people kind of just like, well, duh, you should obviously support that. We get that kind of for free, which is awesome. And accessibility is a huge focus here. We're working both with Unity themselves and with all of our internal teams to get really good accessibility support, because right now Unity UI basically has none of that, unfortunately. And so we are working really hard to build out screen reader type interfaces, text to speech, speech to text, in ways for folks with either maybe not they don't have the physical dexterity to be able to use 3D UIs, or maybe they have limited vision or other limitations. They can use industry standard accessibility tools like screen readers to interact with 3D content in UI. So thank you guys so much for listening. Again, I think the best resources for you guys to reach out to us. We are super active, obviously, on our GitHub discussions and our GitHub issues. We're also active on the Hala Developers Slack. If any of you are members of that, I'll be here in the conference Discord to talk about things, and I'll be hanging around for a Q&A. We are also obviously receptive to PRs. So if you guys see anything you want to change, go submit a PR and we'll accept it. That's the beauty of open source, and we're going to build some awesome things together. So thank you so much.
Hi, Finn. Thank you.
Yeah.
I have several questions, actually.
Okay.
and I also see a question in the Discord chat pops up. The question there is, what is the GitHub link to the project?
I will make sure that it's
but you can put it in the Discord, so that would be good.
Yeah.
So I have a few questions. I love the collaboration with Unity, the fact that you're actually leveraging Unity stuff, because it means when Unity is improving their system, you will automatically use the new improvements instead of waiting till someone is building it in the MRTK. So that's good. What I'm curious about is, but I think you already answered it. One was that is there a support for both controllers as hands on Oculus Quest?
Oh, yes.
because that's the major cool thing at the moment
Yes.
when you
Yes.
use VR headsets.
Yes, yes. So I guess I wanna definitely reiterate that MRTK3 is not just a HoloLens library.
No,
It
it's
is
everything.
absolutely not. We are OpenXR first and foremost. I highly recommend anybody who's interested to go listen to Curtis's talk that he gave earlier. He's kind of our local OpenXR guru. And he can tell you about all the amazing things. But the reality of it is, in MRTK3, you can take the exact same project and deploy it directly to a Quest and directly to a HoloLens with zero configuration change. It's the exact same project.
You don't have to change anything. You can just
Nothing.
deploy it to.
Yes.
Oh, that's cool.
Yes,
I'm definitely
it's
going
really
to try
cool.
that out.
Yes, yeah, it's pretty awesome. The only thing you have to do is you have to make sure that like your deploy settings are set up correctly for both platforms in Unity.
Yeah.
But
and
there's nothing on the MRTK side, and the best thing, you don't even need any of the Meta/Oculus SDK. You don't need a single Oculus. Yeah.
Yeah, the only thing you need to consider, of course, is when you build an experience that it is supposed to be working on both platforms.
Yeah,
of course.
yeah,
But
exactly,
yeah, that makes sense.
Exactly. Yeah.
I love
And
that.
so
It's actually someone confirmed it also in GitHub.
Oh yes. Yeah, and Joost here, he's been an amazing community collaborator with us. He's written a lot of blog posts and articles about his experience with MRTK3, and Joost, you're awesome. Thanks so much for everything you've done. Joost is
definitely.
very cool.
Yeah, he is cool. He was actually one of my old colleagues. So.
Oh really? Oh awesome.
Yeah,
that's
we
fantastic.
worked together at a previous company, and he's of course famous. I'm gonna say it now. HoloLens APC. It was named yesterday too. So it is really cool.
Yeah.
So
Yeah.
oh, he says except for the pass-through. Yeah, I'm
Yes.
curious about that one because
Yes.
I know it's not really part of your talk, but are there any? Is there going to be work on the pass-through stuff? Because that's going to be amazing.
Yes. So that's something we're working on internally for sure. It's a bit tricky, right? Because MRTK was historically for primarily Microsoft devices, right? But these Microsoft devices, we haven't actually had any need for pass-through because it's a HoloLens. You don't need pass-through, right? HoloLens. And so we get support for Quest through OpenXR. It's great, but the problem is that pass-through on Quest is not necessarily implemented the same way through OpenXR that other devices pass-through is implemented. And so we sort of get into this situation where we're going to be implementing specific workarounds and OpenXR compatibility things for like Quest specifically versus other devices that have pass-through. So we're evaluating. We're evaluating what that's going to look like. I mean, as the mixed reality toolkit, we are passionate about supporting all these mixed reality devices, including Quest Pro, that have these awesome pass-through features. So we are absolutely working on it. It is a priority, but it's just
perfect. Yeah, I think if you look at the future, specifically if the HoloLens device is too expensive, then that would definitely be a second good choice. I call it the second choice because it will never be as good as an HoloLens. Not at the moment, let me put it that way, but maybe in the future. So one of the other things...
we do have plenty of Quest devices here, and we also have Quest Pros here, obviously. And so, we test on them. They're one of our primary deployment platforms, so we make sure that it works for sure.
Another question from Jason. What would it take to add compatibility for new platform systems? He's thinking of Cave-like devices, for example.
Yeah. So the compatibility with platforms and systems is completely OpenXR. So it is not a question. So like this is another kind of big difference between the kind of the mindset for developing MRTK2 and MRTK3, right? Like in MRTK2, right? Like say when we came out with Magic Leap support or whatever, right? There was a Magic Leap like plugin basically for MRTK that made the Magic Leap work with that. It's not really how it works in MRTK3 anymore, because we have literally zero code in MRTK that is device specific. Absolutely nothing is device specific. Most things aren't even controllers versus hand specific. And so what the reality is if you have some device, just make sure it works with OpenXR. And if it works with OpenXR, it'll work with MRTK. And another kind of compatibility check is that if it works with XRI, it will also work with MRTK. So
nice.
Because because like if it works with XRI, there's a few kind of things that have to work for XRI to work. Like it has to work with the Unity input system and like a few other things. So like if you've got an XRI somehow working on your device, MRTK should be plug and play. So
cool.
That's kind of the idea.
Other question. I noticed the volumetric UI. I had seen some of it. I got a feeling it's already being used in applications like Mesh Preview app. I think I saw the same kind of UI in the HoloLens.
Yes. So the Mesh app preview for HoloLens is actually built on a fork of MRTK v2. So that project was actually built before MRTK3 came around. But all of our learnings and all of our innovations in that volumetric UI carried forward to MRTK3. So obviously it's all of our user research, all of our testing, all of our interaction design work in them have carried through to MRTK3. Absolutely, it's the same design language, same technologies. But yeah.
I have one other question. That's the last one from my side. Is that myself, I'm working in Unity, but I'm also working in Unreal.
Yes.
And now I know that Unreal can support OpenXR. How is that with the new MRTK? Is that going to work, or
So because most of the reason we built MRTK3 was basically to take advantage of the Unity APIs that came out. MRTK3 is kind of like a Unity specific thing. It's kind of like hey, Unity has all of this new technology, and we would rather just use their technology instead of trying to reinvent ours all the time. So let's use the Unity technology. That's not to say that we don't support Unreal. It's just that saying MRTK3 for Unreal is a little silly in a way, because MRTK3 just kind of means let's use XRI and Unity constructs, right? So, but we absolutely have support for Unreal still, obviously on HoloLens. I'm sure that there will probably be an effort in the future to bring the same design language over. We'll bring those prefabs into Unreal at some point. No commitment there, but MRTK3 specifically a Unity thing, but we definitely still support Unreal.
It makes sense. But hopefully at some point it will also become there will also be a version specifically for Unreal supporting that. Because I think Unreal is definitely going to be also a bigger part playing in the future if you think about Metaverse. But to be honest, I still move a lot of times to Unity instead of Unreal just because it's easier. So no other questions. Thank you so much. Yes. I loved the session. It was great to have you here.
Absolutely. And, thanks for hosting.
If people want to ask questions, please do it in the Discord. Finn will definitely look at it. If not, then later, and he can answer questions for you.
Yeah, for sure.
So thank you for having
so much. Yeah, it was a blast. Thanks.